maybe that, there we go. I think that's enough. I think that's it. That should be it. Let's see here. There we go. That's it. That's the... Whew, alright. Wednesday, 8 o'clock. Stream and whiskey. And see if we can make some lasers going or something. Alright. I'm just gonna check out the Reddit and see if anything showed up that I should be aware of. Probably not. 4 comments. No, nothing. Oh, chicken. Let's see here. So, where were we before? Let's press play and see what happens to see where we are. Okay, so we have a few bugs, all that I remember straight up. First of all, everybody flies away, and second of all, we have the index out of range thing in our physics world. Wait a minute, I'm gonna change the size of the text. I know some people complained that it was too small, and that makes sense. Scale and layout 150 maybe. See what happens. Maybe that's too much, I don't know. I think that's a good thing actually, to have it like that. I think I can code like that. So we have physics world. Okay, so we're gonna so we have the game running probably sort of well. Yeah, you can select. So you can select however you wish, like this, and then you can like move them like this, and then you can double click on the types. And if you double click on the types, you can select every one of that type. I've colored one of the robots red, the flame bots, because it was hard to see for the video that I shot for Reddit. It was hard to see that I actually had like 2 types, so I had to color it. And these red guys gets dragged in this herd here. Anyway, we're gonna make it so they don't jump off everywhere when you what do you call it, when we spawn them, and then we're gonna make sure that that these error is out of the way. And I do believe export physics world, this is most likely a result of, let's just fix this as well, so we have free aspect ratio and not low resolution like that. This is most likely because we are doing something with the collection that export physics world is trying to use. We were doing something with it while export physics is doing something itself, and it looks like, let's see here if we can make this go away. There we go. So 69 haha, nice. Motion data slice coming from somewhere. So we just backtrack this value. We see that it's set somewhere out here in the system, which schedules the job. And then we go in here and we see that this is the dynamic world, that they sort of generate a struct. I already know a little bit about this. They sort of generate a struct that is like a snapshot of the dynamic world that they then use to like calculate everything. So the physics system is not operating on the ECS representation, the entity stuff. It's not operating on that data itself when it's calculating the next frame. It first, let me just fix this. It first makes it into this type of format, and then it calculates the next frame and, you know, everything that collides and all that stuff, and then it exports it back out into the ECS system. So something is clearing out this motion data before we're done with it. And I suspect that this is just some spawn thing, because you know it's 11 errors in the first frame, so it's probably the spawn thing that doesn't really align with the rest of the with the job scheduling. So here we have the instantiation, so when you're looking at these kind of race conditions where a index is somewhere out of range, it's probably because the index is referring to something that is a proper value from the beginning, but you know the array is deallocated, and that's probably because this thing is doing stuff with it before physics export is done. And how about that? Yeah, we obviously update this after build physics, and then it's obviously the wrong one, because export physics is in the end of the frame. So you have build physics, and then you have step physics, and then you have export physics. So it's like build up this representation, and then you go through it, and it's more than step, but sort of step the physics once and then export it back. So we're probably gonna just have to like do this instantiation of the bodies and the prefabs after the export physics is done. That's more or less that's most likely what's going on here. So let's fix that first and foremost. Tariq Larbau, sorry for, and the error is gone. So that was the issue. So you need to you need to understand where stuff is. When these type of race conditions occur, you have to like realize which system is not doing, is not able to like keep its data properly, and then you probably can like derive what system is grabbing the data or destroying the data before, and then you just need to like put them apart so they are not overlapped. That's it, more or less. And Tariq Larbawi, I hope I pronounced that right. Do you use Havoc Physics or Physics package or the other one? I use Unity Physics. So we're 3.1 we have, right? We have PhysX, which is the normal default one that is non-Unity dots. That's the NVIDIA PhysX. And then you have Unity Physics, which is this one, and then you have Havoc. And Unity Physics and Havoc is both physics that is integrated into the Unity ECS and DOTS framework. So I could switch out for Havoc like without doing almost any. I don't think I have to do any code difference except for like specifying that I want to use the Havoc. But I think Havoc has some sort of license tied to it, and in this case it's not really necessary. So no, I'm using Unity Physics. I think Havoc probably has a lot better performance, but you know, maybe if physics turns out to be a bottleneck for me, I might switch and look into if I can use it for cheap or for free. Anyway, but so the guys are still like popping out, flying away, and that's annoying. And that's more or less probably because we are spawning them too close to the ground. So two things I want to do. I want to make them the flamebot and the laserbot like smaller in collision wise, because or maybe not actually for now. That seems actually reasonable. So we have those two, but we wanna spawn them a little bit higher. And you know, this is the kind of stuff where you can have like a black fade into the game if you really want to make it production like really high quality. You probably like just spawn them a little bit above the ground and then have a black fade where they, when the screen is black, fall down on the ground and like settle properly. So then you don't have to like do the weird calculations where you can have like the ground slanted, and then you need to like calculate how far up you need to spawn the capsule to make it not intersect when you spawn them. Instead, you just like put them above with a margin, and then you let them fall down in a black fade. That's usually way more efficient and efficiently spend time solving that issue. So we're just gonna make them spawn a little bit higher. X, Y, start, end. So here we have the, you know, it goes through all the spawn data, finds the prefab, instantiate it, and then we go through them and place them out on different points on the ground with this random XZ position, and then, you know, ray casting it straight down with the ground filter, and then taking the hit position and placing them there. So what we only really need to do is take like new, float 3, and then 0, and then let's put them like maybe 0.2 up, maybe something like that, maybe even more, maybe 0.4. 0.4 seems like a good idea. And then we go back and we make sure it's reloaded and press play. Still a little bit weird. I think it's more or less because they spawn on top of each other. I think that's the bigger issue here, actually, here. So, and you know, the spawning of the is gonna look differently when we have some proper gameplay in place. So we don't really need to bother about that. I think they spawn fine, and I think you can move them fine. I think we should temporarily disable this the like movement that makes them like avoid each other, because funnily enough, spent the whole stream developing that system, and I feel like it isn't really useful yet, at least. We have made a framework to be able to find whoever is closest to you and stuff like that, and it can probably be used for some reason, for some stuff in the future, but right now I feel like this is probably way better. Yeah, you can see the just default workings of the Unity is way more smarter or cleaner looking than what I did on first try in 2 hours. So, but I think it's a good idea to like see where the gameplay is heading, and then like solve the actual problem that the gameplay requires. Like that really sounded like quoting Mike Acton, one of the lead engineers behind the DOTS. He's like, solve the problem, not like try to find problems to solve, just solve the problem. And in this case, we don't really know where the gameplay is headed. So when we know where the gameplay is headed, then we know what type of movement and collision avoidance we need. But this thing works nice, so that's good. That's pretty cool, actually. All right, let's make the big bot, the angry bot, and see what where we can go with that. So we have another bot here that we can use, that my friend and colleague Klaus has made. Giant robot. There we go. So this one is a little bit bigger, but you can see, pretty cool model, I think. I think it really did a really good job with it. So let's create some script for this. So giant bot, not giant bot. That's generic enough for me to confuse it in the future, but let's not get ahead of ourselves. And we have this this model. We can just unpack it and then make a new one here. Let's see here. There we go, giant bot, and then add this giant bot as the script. And right now, I don't think we should like try to push any type of feature onto it. Well, maybe we can do something. Maybe we can do something fun for it to do. Let's just make a public struct giant bot state, and we make this iComponent data like that, and we make the iConvert on entity, or maybe we should just do an authoring thing here. No, screw it. I like having full control over my things, because you know, you can make this stuff generated by using the authoring generate authoring component. Then it will make the game object that I'm trying to make manually right now, that would like automatically have all the fields to fill in to like attach this stuff, this component data to the game object when it's converted to the entity. I've already talked about this, so let's not get bogged down to that. But I want to do this by hand because it feels better, and sometimes I'm just going to do it like that. Entity new like that. We're probably going to put in some data here in the end, so I'm just going to leave that like that. So now this is essentially a tag, which means like the entity is just tagged, like this entity has this component, but there's nothing in the component, so it's just, you know, made more or less a boolean. Let's go back to this one and let's take a look at the sub. So here we have this thing which should shoot lasers and stuff at people. I don't know if I should do anything with it, or if I should just make these the laser bots shoot at him. Let's make the laser bot shoot at him first, and let's make this guy animated later. So let's place him somewhere here where we can have him not static, but you know, close to us but not moving right now. And let's turn him around. Damn it. Like that. So now he's close to us and ready to shoot. No, not ready to shoot, but you know, he looks intimidating at least. So I want to be able to do. First of all, let's make a physics body for this one. Dynamic, and then physics shape, and let's make him wait a minute, what type of shape should I use? That's a weird shape. Cylinder maybe. Yeah, that's good. That's good enough. Maybe something like that. Yeah, we can add for the legs later some other time. Let's not make it too complicated here. And then belongs to, let's make a new physics category. Giant bot. That's good enough. And let's make him part of the giant bot physics thing. And collides with not itself. Well, it's not gonna matter, but it's cleaner this way. So, and then make him convert, because you know, we have the convert functions, and physics body and physics shape from Unity Physics is something that only gets created when you convert it to entity. That's the whole point. And then let's see here. So I want to be able to do something like this. Let's see here where we're at. And he's gonna stand crooked now, I think. Ha! Fun. He flies away because he's too much inside of the ground. Let's make him like that instead. There we go. That's good enough. So I want to just like be able to take all of these guys, move them over, and then, where is he? Move him over and then like right click on him and attack him, right? Yeah, just like right click and then that should be fine. Let's make the camera a little bit higher. It was a little bit close to the screen. 35. Close to the ground, I mean. There we go. So now we can, something like this, yeah. And then, yeah, right click and they should like attack somehow. So let's start with the selection of him and make them get him as a target. Because that's, you know, shuffling data around in ECS. And that's very important to be able to do. So we have the selection UI and the selection system with it. And then we have probably our mouse click and stuff like that. And we have a right click that we can detect and use for whatever. I think we only use it in one place. Right now we detect it, we work with it, and then we use it in the unit thing to move them. Yeah, so right click here. This is where we're at. So this code detects that we have right clicked, and then it uses that right click to create an array, and then we find the ground, and then that ground is used for, well, this hit info is used to know where we're going. So essentially what we want to do is we want to modify this filter, because right now the filter will collect everything that is underneath us, including, you know, if there's something with collision really high far up in the air, then we will click on that as well, and that's not really necessary. We only need the ground and the units. So we can, I think selection UI is where this should be. Unit physics tag, let's add a giant bot physics tag. I'm using unit and bot a little bit interchangeably here, I realize. Unit, I think, will refer to everything that is sort of controllable by you, and then I will name anything else whatever I want, and giant bot seems like a good idea. So that's how I'm gonna do it. So physics tag, blah blah blah, and then we can use this. Yeah, so I'm going to introduce a new concept which I've been working with myself quite a bit, and I think I really like it. And this is actually pretty interesting. So I watched a what's its name, GDC, Game Developer Conference talk, a GDC talk by one of the developers behind Overwatch. And Overwatch is made in a similar ECS system. They don't use Unity or any other engine that you could use, obviously. They use their own proprietary in-house created one. And they created an ECS entity component system for that game. And they were very pleased with the structure of it. And if you watch that thing and you have some knowledge about ECS in Unity, you will see a lot of similarities. They work very, very similar to each other, although that is coded in C++. So that allows you to do a lot more flexible and not that safe stuff. But, you know, they are professionals and they have worked with C++ a lot, so they do it, you know, the more wild way, and we inside of C# and Unity do it in a way more typed, controlled way. Anyway, long story, but I recommend watching that video. It's really interesting. But one of the things that they realized is that they put a lot of states, variables, whatever, stuff that holds a value or something. They put a lot of these variables and states inside of systems. and they realized that there wasn't really a clean way of expanding variables where they should be located and stuff like that. And they were like, well, if it only exists one of them, why should we associate it with an entity? Because data in an entity system is normally associated with a component, and thereby an entity with a lot of component or whatever. But they we don't need an entity or component with this data, because it's only going to ever exist one of them. So why associate it with an entity? But what they realized is that it's better to do it like that, to have the data that is universal, ambiguous, and universal, and just one of them, like game mode stuff, sort of. It's nice to have that associated with only with an entity either way, because it makes it even cleaner. Only data inside of components with the entities, and no data or state or whatsoever inside of systems. So they converted their game code to have all of the global data, all game manager, all those meta type of things, game mode and meta and stuff like that. They converted that into to live on what they call singleton entities. So singletons, for it's a word for something that only exists for only one can ever exist, and should only ever exist. And Unity ECS has the equivalent. They have something exactly called singleton. So without that out of the way, I'm going to introduce how singleton works and why we should swap this, because here you can see a perfect example of the problem that I pointed out. So here we have the filter that is used to raycast the ground and find characters, and that filter lives straight into the system, right? And that's not necessary. It doesn't need to live here. So we're going to move that into a singleton, and let's make this singleton. So the way you do that is you take public struct selection data, just a generic name to this is stuff that has to do with selection, and then we inherit from component data, and then we take this unit filter and we put it here. Just copy and paste it right there, and then let's add another one, and that should be target filter. Let's see here. This one is the double click, and the double click thing where you double click and you try. That should double click to select one type. That only works if you're actually hitting a type, which is why we're still gonna need this unique unit filter to hit units with it, only units, because that's the only thing that makes sense. And then we're gonna have a parallel one, which is everything you could right click on. So this is for the double click to select the type, and this is for the right click to go somewhere or attack something. And by putting it here, it's in a component like any other, and right here we are normally putting it inside of the system, but let's do it like this instead. So variable selection data entity. We probably need to put it. No, we have this one. This is. Let's make a shorter one. World. This is such a long goddamn thing. They use this is a reference to the default world, and they had a shorter world name before, but they realized people used it too much and in the wrong places. So they just named it to a really long and convoluted weird name to make people realize that this is a pretty special type of variable, and I shouldn't use it unless I know what it is. And in this case I know what it is, so I'm going to use it, but I'm just renaming it here to not have to type this or have this long ass names. Anyway, world dot entity manager create entity like that, and then we're gonna do, and here is the trick. So we do add component data to the selection entity, and then new selection data like that. And we have the unit filter, which is this one, you know, we already made that. And then we can, wrong one, and we can remove this, and let's make another one. So something like this, unit filter, target, unit filter, like that. And then instead of this unit physics tag, we use the giant bot physics tag. Let's target physics tag. Yeah, that seems reasonable. So this is, you know, still, this is everything we could target with a right click, and then use that. So now we have the proper target filter, right? And we put that inside of this one, like that. And now we have the selection data, just one entity with it, and inserted, right? So how do we get this? This is no longer in the system straight up. So how do we get access to that new? So here's how it looks. Can do it like this actually. Variable selection data, and then we use get singleton. So what that does in the background is more or less, in the fastest way possible, gets the single entity that owns a selection data component and just bring it back and nothing else. So now we have like a way to get the data wherever we want. So it's not tied to a system, because the system is just going to crunch and do the actual logic, while the data shouldn't be tied to any system. So now the data is just floating in space inside of the entity pool or entity registry. And whenever you need it, you're just like, I'm gonna need the selection data. I know I only have one of them, so give me the one. And the system will give it to you and you can use it. So it's a much cleaner way of doing this. So that's how singleton work in Unity ECS. And then if you would want to change this, so if you had some situation where you like new whatever, want to reset that, then there's a set singleton. And this is actually, with the type system in C#, this becomes really clean, because the type is implicit because this one already has the correct type. So you just like, oh yeah, set this data back. You know what type it is, you know where it should be, you know which one you should overwrite. Just do it for me. So that's pretty simple. But right now this is just never going to change. So that's nice. So let's see here. Now we have that one, and let's so now we can use that one instead of the right-click collision one, right? Because this one is default, so that means that we can go anywhere on anything, and it will, raycast on the ground and collide with anything, not just the ground or units. And that's not good, because we might have something in the way in the future. So we're gonna just copy this singleton data thing, and we can put it here. And then we have the target filter right here. Let's just make sure unit filter there and target filter there. So now we have the correct filter to find targets and ground, or the right click filter, more or less. And now we can't really just pick up this right click and be done with it. We need to see, did we hit a unit? And I think we have an interesting thing here where we can again be very smart with ECS. So let's make a new entity, a component I mean. So if we go up here, we have the unit data, let's make something else. Struct target target tag. We might rename this in the future, but let's do it like this for now. And just to be consistent and show you, this doesn't need to be public, so let's just make it normal. Since everything is in the same assembly, it's not or in the same namespace, it doesn't need to be public. I just think it looks cleaner. Anyway, so we're gonna associate target tag with targetable units, stuff that you can actually attack. So if we go back to giant robots and we do something like this, test manager add component. I mean, we can do this single line thing for this one as well, but I know we're gonna put stuff here into the giant bot state, so I leave it like this. But anyway, we just add this target tag to this giant bot, and now what we can do is right here in the hit. So let's do it like this. Let's if, because we don't know if we hit anything, and let's put that into brackets. And now we have the hit info and we have the entity that we hit, right? And we can do like this. If has component target tag. Else. So, and it's not harder than that to like find out if something is what do you think it is, or find out if something has a component. You're just like, oh, the one we hit, does it have this component? And it's really fast, really good way of sorting and stuff. So let's see here. Right click is used somewhere here. Yes, select right click. So this code just assumes that we have right clicked the ground and moves us there. Has target position, right? But that might not be the case. Right click is true when we just right click, and now we don't actually know if we right click the ground or a unit, but we know that inside of here. So what we can do is that let's rename this. We can put that inside of there, and let's name this ground right click ground equals to false, and then we do it like this, true. So now we only set it to true when we actually find something that doesn't have the target tag. Right click ground like that, and then but we want to deal with the guys with the situation where we right click the robot but still have him selected. So let's move this over like this. If and then else, let's else and then we do has target entity true, and we can generate that property and like that, has target entity. And then we go back here and now we just need to make sure that so if we make somebody move, should they lose their target? Yeah. And if we make somebody has a target, they should lose their target position. Yes, that sounds reasonable. And then we should have target entity like this, and let's just make entity.null just to make it possible to auto-generate this with the proper type like that. and I just, yeah, I sort them by type usually because that makes it easier to pack, I think. I'm not entirely sure about that actually, but whatever, it doesn't really matter. So let's go back to the unit. I think I lost my connection for a second there. That's strange, never happened before. Anyway, let's recap. I've right, that should be right, not right. So we need to figure out if we actually hit something and what we hit. So target clicked equals to false, and then target entity, that's variable target entity dot null, like that, and then we make it true, and target get entity equals to hit info, like that. And well, now we actually can have a else if statement here to make it just really clear what we're doing. And I'm gonna swap them in place because they have that place further down. So let's just, I'm just, yeah, moving around stuff here. It's not a big deal. And that one should be there. Data, target entity. So target clicked, blah, blah, blah. And we have the target here that we save over and we put it right here. So now we have the target. How about that? Let's make him attack, like straight away. With the laser, how do we do this? So we want to make him shoot laser. How does it look? Oh, I have something. No, I haven't. Just saved. There we go. So let's take a look at the laserbot and see if we can. So he has the arm. Oh no, it actually is. My friend will have to move the pivot a little bit because this is maybe not how arms work even on robots, I guess. But anyway, it's good for now. We can point that. So the forward is the Z, so let's just point the Z vector. We can attach a laser to him. So let's not get bogged down in VFX straight away. Let's just make some random mesh that just points like really, really far, and then make him just enable that whenever we are shooting. And when we're not shooting, we disable it. And that should be our laser. That's good enough. I think that will actually look kind of nice. And we can even make it a little bit radiant emissive material. And let's call it laser. And let's make it super red. And I know that the emissive is probably not going to work because of the rendering. Hybrid renderer is not really working too well with emissive for some reason, but we can fix that because I can show how to fix that. So let's take just a cube and remove the box collider and then make it smaller like this. I think we can make it like maybe 0.05, so 5 centimeter in diameter, I don't know how that's actually pronounced. And yeah, that should be nice. We can do like this actually, so we can see if it's perfectly centered, like that. Seems good. And then we make it really far, like 1,000, I don't know, seems like a good idea. And then we move it over like 500, 501, 500, like that, and we put it on the laser. Nice, we have a laser. Huh? Actually, if we no, that's fine. A kilometer of laser, that's good enough. If we see the end of it, then in game, then we should just extend it to make the illusion better. But this seems fine. Let's go to the laser bot and let's add something up here. So we have a laser like that, and we can convert this sucker and take the laser and we put it laser like that, and then we generate this thingy here, public, like that. So we have the laser, and the first thing we can do is, so this is a nice trick, we can take the test manager, the entity manager, and we can add component disable rendering like that, because then it doesn't really matter if we are turning, if we forgot to turn it on or off when we save the what do you call it, the prefab, because we're gonna immediately turn it off. Disable rendering is just a tag that just makes it so it doesn't render it at all, specifically in the hybrid renderer, and it's a little bit counterintuitive sometimes to use, but yeah, in this case it's really effective to use. So now we can do like that, and we have the reference to it, and so let's see here. Here we have the target locked or target entity like that, and let's point this sucker. So if target entity, so remember the reason why this is in another if statement than this one, or this one specifically, it's because this will only be set when he's selected, when the unit is selected. Then this will run every frame, so it will shoot every frame, right? So we need to find a direction to point this. Oh, actually, we need to make it like this. Let's see here. Laser beam, and no, yeah, that's because we need to point this one, right, his hand, but we need to turn this one on and off, so that's different. And that's one of the things that is tricky with ECS sometimes, because if you put the disable rendering or some other modifying tag on a entity, the children, if you have children, will not be affected by that. And it's the case also with Unity, putting the disable rendering on top of the laser beam or the laser is the same as unchecking this mesh render. Like if we uncheck the mesh render of this arm, it will not make this child disappear. But it's still like you need to remember that there's a difference between disabling the rendering and disabling the whole thing. And even if you disable the whole thing, I think the children will still work somehow. I don't know. That is strange. It's not as straightforward as in game object in traditional Unity. The hierarchy works in a little bit differently in ECS. But anyway, let's focus on the target or the goal, and let's make another one, laser beam instead, and we can do like this, bam bam laser, and we should add the disable rendering to that one instead, and then we can add the laser beam like this. So we have both of them, because one of them we need to aim, and the other one we need to turn on and off to make the laser go blinky blinky. So now we have those two, and we have the proper ones, and if we go back to Unity, we will hopefully see both of them here. So we put laser in the let's see here, laser bot unit, there we go. Oh, wait a minute, this is supposed to be in the laser bot thingy. Let's just fix that. Laserbot. Okay, so here we have an authoring component. So that's actually not the best way of doing this. Screw it. I think it's good enough. So let's remove that. So now instead of using this convert, this laserbot component with authoring, that will generate a similar thing. The only difference right now is we won't have disable rendering, but I just realized that, you know, it will actually be added on the first frame, so it doesn't really matter. And if that's annoying, we, you know, can just disable it here. Let's see here. We can just disable the mesh render, and that's the same thing more or less. I think we can confirm that. But if we go back here, so now we have the on the laserbot we have these both. So let's move that up actually to wrong one. Move up, move up, move up. So convert to unity, unit, and laserbot, and then laser and laser beam. So that's nice. So let's fix the other thing here. We need to target the thing, right? I mean, we only have the unit data. So we need to make another one. We actually need to move this. So I'm gonna explain why in a second. So let's make another one of these. Schedule parallel. And we can remove buckets, transform, and we can do like this. I think that's just in and trans and oh, but we are actually modifying something that's not us, so we don't need to do it in a separate one. Yeah, never mind. We don't need that. So the reason why I thought about this like this is because when you have these entities for each with references right here, then you can change the translation of several of these entities parallel perfectly in super tight and thread safely system, because, you know, it's only iterating through the entities with all of these, and like no other loop or system or thread in the computer right now is allowed to touch this, so or read from it also, so it can just spin through it super easily and change anything it wants. And I thought I would do the same thing with a laser, so we could just like go through all of the lasers super paralleled and make all the bots aim their lasers all at the same time. And that would probably be quite good. But the problem is the laser is not the laser entity is not the entity that we are iterating over, because this laser and this laser bot, that's the unit and laser bot thing we are iterating over. The laser that we want to aim and turn it on and off is these two, and these two will be generated as two separate entities. So we can't reach them either way, because we can't iterate on several types of entities at the same time. So what we need to do is we need to produce the results, the aiming results, into an entity buffer, so we can apply it later. Or so we can sort of like change something on another entity that we are not iterating over right now. So that means that we need to get a hold of the next frame, or the next part in the frame. And that's not that hard. Let's do like this. Private dot end simulation entity command buffer system. That's a mouthful. Let's call it ECB system. That's what people usually call them. And let's do it like this. And we actually did this in the beginning of this series, but I'm gonna take a quick explanation of how this works in a minute. Variable command buffer create to concurrent. Yes. So this thing, we are right now in the simulation system group. This system, so this is a system just like this one. This will run in the end of the simulation after this group, and it will execute command buffers. That's literally what it does. That's all it does. And so what we can do is that we can like queue up a bunch of different command buffers that when all of the simulation systems are over, then this one, that is the end of the simulation, then it crunches through all of the different entity buffers, command buffers that we have actually created for it or given it. So this is how we do it. So create command buffer. We create one buffer that we fill it, and then so like, okay, give me a bucket, putting a bunch of instructions into the bucket, and then back to it. Like, yeah, do it whenever the simulation frame is over. So now we can use this command buffer to move the thing here. So let's find the angle for the thingy where we are aiming. So we have the target. So let's do a target trans, and let's get a component local to, sorry about that, local to world, and then we do data.target entity like that, and then we have a direction, target dir, and then we go position, and then we have ourselves here. Sort of. We don't want to move it from the point of view of this root point down here. That would be awkward. So it's better to have it like from this root point. So we should aim it from that point of view. So laser trans, and then we put in laser. Let's see here. Variable laser bot. Another small block here. So I might have to revert once again. So the reason why I got stuck here is that the laser thing, you know, that exists on the laserbot component, and we don't have it, right? We can pick it out. Yeah, we should pick it out, because then we can have one. This might be a good idea to split up later. So we could actually choose like the unit data and the local to world trans and stuff like that. We could pick that out in a new entities for each, and then also put in laserbot, the laserbot data as one of these in parameters, and then use that right here. But we can also do it right here. It's just that we need to do like this. If has component laserbot loser laser bot like that, and then we take the entity we are on right now. So are we a laserbot? That's what it says. Are we a laserbot? And if we are a laserbot, let's pick out this laserbot component, get like that, and then we can use the laserbot component laser. So now we have that component, and you know, if we are inside of a flamebot, this won't trigger obviously. So we go from laserbot position to target position, and then we have the actual direction of the bot of the arm. So let's just aim it. That it's not that hard. So let's see here. Let me think. Variable laser root, and then quaternion with small q to find the fast DOTS version of the math library is quaternion with a small q or math with a small m. So look rotation, and then we have the forward, which is this one, and then we're probably not going to aim straight up in the air, so we can just put in the typical straight up in the air vector as the up vector. You know, if this target direction would be straight up in the air, then this look rotation will not be able to create a quaternion that at the same time is aimed straight up but still has its local up vector straight up. That's not possible. So but anyway, we're not going to aim straight up, so we can just put a normal up vector here as the reference up. So now we have the rotation of it. So now we can do something like this, where we take the command buffer that we have and set component to the laser, and we need the job index, so that's important to realize. So job index, I think I have that actually in some other place here. I'm just gonna check to see if this is used anywhere. No, I don't use it anywhere actually. Yes, I do. There we go. I just wanted... Oh, I don't use it. That's weird. That's weird of me. But there we go. So I'm just gonna put that inside of here and then explain to what this is all about. Like this. And then laser rotation. Like that. So, new rotation value. Laser like that. So what happens here is that we have our command buffer, you know, which is a bucket with instructions for the next part of the frame. And when we are doing this, we are doing it in parallel. So we need to sort of order the instructions somehow. And this entity inquiry index is just the ID, the index of this particular entity in the long queue that we are iterating over. We're still iterating over it parallel, so a lot of different threads can be working on it at the same time. But all of the different entities still has its own unique ID. So then this component buffer will know which set component instructions came in which order. So that's basically it. So we are setting the component, a component on the laser entity, and we're setting the rotation of it. So now it's gonna aim. And we don't really need to do much more right now, because the thing is that when we are picking out a command buffer from the ECB system, from the end simulation command buffer system, when this end simulation system kicks in after the simulation group, it will automatically crunch all of the different buffer that has been created with it. So we don't need to do more. It will work. Right now we just need to make sure that we have the entity, has target entity, that is working. Let's see what happens. I have no idea. Well, I have some idea, but you know. And we can actually turn on the beam, and let's just not flip it on and off and whatever, and let's just have it on permanently for now, and remove these two because those are not needed anymore. There we go. And let's back out and let's make that disabled. Two things I remember. Selection, so the selector thingy that we have somewhere here, canvas, or is it here? No, it's somewhere. Canvas, dragging root, selection UI. So here we have the unit physics tag, and then we have a target physics tag, and the target physics tag should be ground and giant bot. So that's the targets we can have. So that means that we can't target one bot to another bot, but the the units or the bots, small bots, can only target the giant bot. And then we need to make sure that the giant bot is in the giant, yeah, so belongs to that. A lot of code without testing. Well, that looks interesting, but you know, they are not obviously not aiming at the right. So let's pick out the let's do it like this. So now we can just take the red ones and the green ones and move them like that. Oh, I realized how this is gonna be. So before we try to, because you know we want to right click this one and see if all of the lasers turn straight into it. The problem right now, I realize, is that the rotation that I calculated, it's not in world, or well, it is in world, is calculated in world rotation, in world coordinates, but it's not applied in world coordinates. It's applied locally. So let's right click and see everything spread out like weird. Yeah. So you saw them there doing something. Yeah, you can see you can see them all turn somehow, and the reason why they don't turn to the right side is because they are all applying this aim in local space when the aim variable itself is in world space. So let's do two things. Let's make sure that the flip the laser on and off depending on if they have a target or not, and let's and then let's make them aim it properly in world space. So now we can do like this. If has component, and then we have the disable rendering. Let's see here. This actually needs to be outside here. So this is an interesting, tricky thing, because the thing is that if we have a target, we want to aim our stuff at it, right? So we can do it like this for now, and I will explain why this is a little bit annoying. So if we have the disable rendering on the laser beam, that means it's not showing, but it should show because we have a target. So then we remove it. So then we do something like this, remove component, and we can bam, 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 and we put in the, so we remove the, let's see here. So we remove this component that we have to make it visible again. But then we have the situation where if we don't have a target, we need to do this all over to make sure we even are a laser bot. So you know, that's annoying. We can do like this instead. Variable laser bot. Yeah, that's a good idea. So now we don't need to actually check that is twice is laserbot, and then we do it like that, and yes, but this else, yeah. It's just how which one you put in to, you know, we could flip the depth of both of these if statements and make like sorting on the bot type first and then on has a target entity or not. But right now I think this will work fine. Yeah, and now we need to flip this. So, you know, if we don't have a target entity, then we go in here, and if we are a laserbot and we don't have a disable rendering, that means that we're actually showing the laser beam. It doesn't have a disable rendering. So then we need to add disable rendering to not show the laser beam when we don't have a target. It's really upside down to think about this not. And whatever you want to call it. It's really strange to think about. I think this is gonna work actually. So let's try that. We haven't rotated the stuff, and I think this is a good start. Well, obviously I was wrong. Is laserbot, laser beam. We can just, so now we can check this out. So if we go to analysis, entity debugger, and then we find all our laserbots, and then we take a random one, we can see that we have a has target entity equals to false. So that means that has target entity goes here, and it is a laserbot. And then we pick out the laserbots, and then we take a look at the laser beam, and the laser beam have disabled rendering, but we're still showing it. What the hell? So it's working. You can see how we have the disabled rendering, but we see all of these damn lasers. What's going on here? Laser disable rendering. This is super strange. This is really wow. What? And they still have their hands, so we're not like hiding their hands or something other weird. So disable renderings should disable this whole thing. Are we like not on hybrid rendering v2? And I don't even get any console outputs. What's up with that? Project settings, player. I'm looking for the defines. Wait a minute. Yeah, we have to be on HDRP, right? Yeah, we're on HDRP. That's really strange. You know what? Screw it. Let's just make it disabled instead. Disabled. So there's another one called disabled, and that's just turning on and off the whole thing. Everything that is associated with it. So that might do the trick actually. That's very strange. I use disable rendering all the time in other project. It might be, yeah, there we go. And now if we take the red ones and we move them back, and we take the green ones and we move them here, and then we, bam, right? So that's better. And you can see how most of them are aiming sort of at the right point, but the problem is that they are, it's just because they're really close to the 0 point on the map, and that's why their weird aiming math almost works. You know, a broken clock is wrong. Is right 2 times a day, so that's the same thing here. So what we need to do is just invert the direction, or the quaternion, the rotation, with the global rotation of the unit. It's actually a lot easier than it sounds. So the only thing we really need to do is go into laser and realize that, okay, so its parent is the actual entity that we are iterating on, and we need to take its rotation. We need to take its rotation in the world and inverse that on top of this one, or you know, this one should be on top of the inversed rotation of the whole thing. Quaternion math is actually quite goddamn brilliant. It's just that it's so hard to get your head around it the first time. So now you're gonna see, this is just, it's just impossible to explain how this thing works out unless you know quaternion. So inverse And then this is a little bit annoying. Normally you can just like, oh, I think it's inside of this one, right? Nope, it's inside of that one. Rotation, oh, it's the value inside. So a rotation there is, you know, it's the whole rotation component, but inside you have the actual quaternion, that's the whole thing, but it's still inside, so that's why we use value. And then you can't do like this, quaternion times quaternion, because this this operator is disabled in DOTS, because you need to use the math dot mul, as in multiply, and then comma like that. And the reason is because multiply, you need to use this whole thing inside of unity dots, because it's vectorized by default. Everything you do with it is sort of vectorized, which means that it's like it calculates on a lot of when it does the calculation, it does it on a whole bunch of values at the same time. And if you don't use that math, you won't get that performance boost. So let's see if I was right or wrong. I'm very curious. There we go. That looks kind of cool, actually. How about that? Laser! I don't know why I said it like that. Laser is... yeah, we need to swap that for an effect. But you see... oh, then we need to scale it. But you know, fuck it, it can be like a penetrating laser for now. So... I'm just gonna make one thing that I think everybody is annoyed that I haven't done yet. And that's go to the movement script. See here. So first of all, with the movement, they don't look at in the direction they're moving right now, and that looks completely retarded. So let's make them move in the look in the proper direction. So if you take a few here and do like that, you can see they are just like strafing along like they don't care, and that's, you know, not the most visually stunning thing. So let's just make them do that. Has target position. Yeah. Now we have the rotation, so we can fix the rotation. So we need to project it. We need to take their direction, so they have direction where they are moving, and we need to project it to make it flat, so they don't, like, you know, look up. So they move standing straight up. Did I import any? No. So I'm gonna just steal this code from my other project. Let's see here. Of math utilities. Then we have project on plane, project point on project vector on plane, like that. And then let's create a new math utilities. Math utilities, like that, and then put it straight into here, remove this one and do it like that, and then public static class, and then implement or import all of the different stuff. There we go. And let's go back here, and then let's variable flat direction, like that. Direction, project vector on plane, and then we take the direction and we just project it on the up vector, like that. And then we do the variable unit rot quaternion look, and then we do the flat direction. So we need to make sure that this is not like 0. So if math dot length squared is over 0.0 1f or something. That sounds good. Then we do this because you know, you can't aim yourself at yourself. You need to aim somewhere else than yourself. So this direction, you know, well, we should actually do like this instead. Has target position, and then we should put this whole thing, because we can't move anywhere unless we have a valid direction either. So flat direction, look direction, and then we have the, and like I said, we probably won't move straight up, so we can use the up vector as the up reference, and then we have the same thing as we're doing here. So the rotation. No, we don't need that. We don't need to use the command buffer because now we are actually iterating. Yes, we do. Okay, learning time. Unity dots learning time. So rot, right, is inputted into this this for each loop with the in. So that means that this is fixed. Well, you can change. I don't know if you can change it. It doesn't matter. It will not change the actual value in the behind the scenes, right? And we could do like this, ref, and then you know, take the rotation of the actual unit and set the value to this quaternion that we just created. So we have the direction, the flat direction, and we set the actual rotation of it with that. This would work normally. The problem is that Unity has a very, very clever, I don't know if it's very clever, but as a as somebody who hasn't programmed too much parallel stuff, I think is quite clever, because I wouldn't have come up with this stuff if I tried. So the reason we can't do this right now, we cannot do it, and the reason is complicated, but not so complicated. The reason is that we are also trying to write to rotation. No, wait a minute, we can do this. I'm sorry, I'm confusing everybody. Let's just move this here. It looks nicer. I think I can actually turn it. Let's see. Let's just try it. I maybe get an error here, and if I get that, I know exactly why. So if we take these guys, oh, so they actually, yeah, that's interesting. Well, that was not what I was expecting, but we can actually move. We can rotate them. So I mean, anyway, wow, that's retarded. I wonder what I'm doing wrong actually, because I mean, I'm projecting it straight down onto the plane. Project vector onto plane. This should not be anything else but, you know, just straight look direction forward, and their forward is their normal forward, right? What the hell is going on? Project vector onto plane. Plane and normal. Oh, ha! See, okay, plane normal is first, and then we have the vector. That's it. That's the reason. And I'm gonna make a small, quick explanation of why it didn't. The other thing about rotation and thread safety, so I don't confuse everybody. There we go. So you can see how they are not moving particularly graciously, but it's better than before anyway. yeah, I'm pretty happy with that. And if we move them over here, we can probably make, yeah, so that makes sense. So only the green ones, the laser bots, actually moved, and you can see how they keep the target proper. Keeps their eyes on the target or whatever, because that part of the algorithm is always running, even if they're not selected or anything. But their body movement is being a little bit strange. This actually looks kind of cool, even though this going through is pretty weird. But it's an okay visual thing. I think it's, yeah, I like it. So let's fix so even when they are aiming. So I think actually, let me show you what I mean. Let me show you why this is a little bit funny and need to be addressed. So if I take a few of them here and I put them here, and then we go and check them out, you can see how, yeah, that's not like the way it should be, right? You see what I mean? So we should just take this one and put that here as well. Direction, target direction, like that. Flat unit direction. That should be it. We just project the target direction instead, and use that one the exact same way as we did before. So now they might be doing something right again. Let's see. Let's select a few of them and then do like that. Yeah. So these guys looks, yeah, everybody is pointing at the same, and they are really only turning this this thing up and down, right? Because they are all pointing in the right direction. So that's pretty cool. I want to fix two things about the laser, because maybe we won't need an actual laser effect yet, because maybe we can just take the laser and make it the right length and then make it emissive, and then nobody will notice that it's just a box that is scaled. So let's make it emissive. First of all, the emissive thing is weird, but I'm gonna show you. So they like, if we make this laser thing emissive with the emissive thing here, it will not matter, because it just, so now it's super emissive. If we look at the bot, the laser bot right here, it has a super emissive one, right? Looks really nice. If we take away the emissiveness, so that's the difference between none and, you can see it's emissive if I wanted to. Anyway, I'm gonna show, so if we have it like that, if we have it like that and we press play, it will not keep being emissive, because Unity has a bug in their rendering, in this part of the rendering, which makes the, wait a minute, am I wrong? That actually looks emissive. Let's make it like weird green something. Oh, wrong one. Green. I think it's actually not working, but I'm not sure. Ah, it's working. How about that? So we can just leave it like that. That's perfect. All right then. So let's do it the super red thingy, and let's make it like really emissive. And let's add bloom to our main camera so it like bam blows up properly. We have the volume and we should have some post process. There we go, the bloom, and the threshold is right now the intensity is quite low, so we can put it a little bit higher and we will hopefully see a little bit better blooming. This is annoying that I can't move it without moving the camera. Let's see if we can do like this instead. So we can, yeah. So let's take it 5 and maybe have 1 in threshold, so only these ones show up. So that looks nice. I thought they would bloom way more than this, but I don't know. Might be a little bit off. Let's take their laser beam and make it not cast shadow, because it should not cast a laser can't cast shadow. That would be stupid. And let's take a look if there's something else we can make. Cast shadow off, contribute to global illumination. No probes, additional settings per motion. Yeah, that should be enough. Yeah. So let's just scale them also. Let's scale these guys. So we have the laser, and we first of all, there's like a ton of different type of scaling components. So normally you have the XYZ components to scale a game object. In Unity ECS you have a scale, ununiform scale, and like a third one. I think you have 3 different scale values. So let's just check which one these guys have, because it depends on how they are generated in the conversion script. So let's see here, filter, laser bot, and then we take this laser beam, and then we take a look, and they have the non-uniform scale. So this one is the one they have. So non-uniform scale. So we need to change the Z and their position. So let's see here. Here we have the target direction, right? And this one is actually not normalized. I realize that now. Let's normalize it once. Variable normalized target direction, math normalize, yeah, I think that's fair enough. Flat direction, blah blah blah, like that. That's good. And then let's calculate the midpoint. So this is the midpoint between the arm and the target, and that's the midpoint where we should place our long laser beam, and then scale it along that thing, right? So the midpoint should be the start point plus the let's rename this target vec. So it's like the whole vector, not just the direction, and then halfway there. So from here to here, now we have the vector, and then we take this point that we start at, and we take half the vector plus that one, so we end up just halfway. And then we should find out. Then we take the variable local, because this is in world space. So we take the local midpoint, which should be this is actually trickier than I thought. Maybe we should just move this thing out of the hierarchy, because right now I need to like calculate the midpoint, which needs to be like No, I don't need to calculate the midpoint. I just need to put it along the same axis that I did before. You know, we have the laser bot and we have the. It's just that I need to. God damn it! This one, I need to just put it as far along this. So we just need to change the z to whatever this length is, half of this length. So let's take out the laser beam beam position, and then let's take the translation of the laser beam. Translation like that. So we have the position, and then we take the position and we take the z value, so it's still like a value inside of the component, and we take the z value and we take the math.length, and then half of that. So that should be halfway, and then we should take the non-uniform scale. So remember they had a scale component as well, and we should take that value z, and then we should have the same thing more or less, I think. Value, we can do it like this. So we just push that over to that one as well, and then we should set these two values, right? Laser beam. So we can do it like this. Laser beam, we're setting the translation to this component that we just changed, and then we do the same thing with the scalar. Scale. So we update this, we move it forward, and then we shrink it so it's just between those two. That might be the right thing. For which cannot use component cases get with the same time. Okay, so yeah, here we have one of these issues that I didn't properly explain before. So now we're getting this is race condition type of prevention. So we're iterating over the translation, and we have ref, so we can change it if we want to, because we are moving it, right? We're moving it right here. But we can't. But since we are actually iterating over these, right? We can't pick out another random translation, because it might be ourselves, it might be somebody else, it might be one that another of these parallel for each loops are already looping over. So if we are putting in this reft translation, so we can change it, right? We can change the translation inside of this loop. Then we can't pull out another one in the same, because this one, it might refer to another one that the other thread is already working on. They can't guarantee thread safetyness if we allow us to do this. So the way to solve it is to remove this one here, right? So now we're gonna get a few errors. So this one and this one, but then we take first of all, this one is our own entity position, new position, and we can actually use the translation component instead of the float inside. So new position, and then we set it back, and we do that with the same trick, with the same command buffer. because the reason why we allow to do this in the command buffer is because this command buffer is delayed until this scheduled parallel is already over. So we can't have any parallel conflicts if we apply this set component after everything, right? That's why it works. So we basically moved it over from being able to iterate straight over it to only being able to get it like this with a get component and then pushing it out into a command buffer as a delayed application. So this might actually work if I made this thing work properly. So now we actually don't need to have this long thing. Cannot access get computer at the same time. Oh, I didn't press refresh. It was the same issue as before. And let's just because it's much nicer, let's make this 0 or I don't know 1 and then 0 like that, because you know now we are actually setting its z value every frame, so we don't need to. And let's do this with a cylinder instead. Oh, so now we need to rotate it 90 degrees and put this over here and there. That's much better. And let's change the y values instead. No, y and still z. Still z position. So we make the z scale larger. No, y, z. We make the z scale larger. No, did I do it wrong again? Yeah, I did wrong again. The y scale longer, like that, and then we move it along the z position. Position z. That's right. Whew. I wonder why they all are on the same. Did I? What? Lazybot, Flamebot, what did I do? It looks like they're like on top of each other. Yes. What's up with that? Oh, I think, no? What's up with that? Belong to, Lazybot doesn't need to belong to player. Should hit it, yes. And then Flamebot, belong to only unit, god damn it, and collides with ground and unit. That's very, very strange. I think it has to do something with this one. I'm gonna put that inside of here. That's super strange. It's almost like they are... What? I have no idea what's going on. Okay, never mind. Now it works again. Oh well, let's see if they aim properly. Yep. They have some other issues, but... So if we just pick out these guys... Pretty funny how they... Whoops. How about that? But anyway, they don't. I'm curious to why they are like on top of each other all the time. They need to have some better local avoidance, I guess. We can move one of these guys and how about that? That looks like something nice. Let's what happens if we like take away a lot of light? And we go to the post processing and pick out a exposure, and then we take fixed. There we go. Now we're getting somewhere. Whew, I think that looks pretty nice. So they are actually, yeah. Well, I mean, it's super, very, very much, yeah. They're very, very, very much flying away as soon as I do something like that. That's strange. Okay, so it's happening. Yeah, I need to figure out what's going on. It's happening because something is rotating and they get stuck inside of the ground. Or you know, they rotate and they get something underneath the ground, and then they like fly super far away because of that. And when they then, you know, collide with the ground that they are clipping with, they just fly away. Yeah, that annoys me. But I mean, heyo. That's gonna be a pretty nice visual look when I get everything working properly. And then, you know, taking the fog and bringing it up a little bit, maybe like that. A little bit thicker. Yeah, that's that looks pretty cool, I think. Huh. Maybe like 80 or something, and then 100. Yeah. I think I'm done there, actually. I think I'm pretty satisfied with that. I need to rest my brain a little bit. Poor guy is really, yeah. I think I know why that is. It's easy to fix. It's more or less because he's, you know, trying to move to the point which is himself. So and then the rotation becomes all screwed up because he's trying to project a direction which is basically a direction that says 0, 0, 0, because you're already on the right point, and then the direction calculation becomes all completely whack, or the quaternion calculation. So anyway, I think that's it for now. Oh, that's really bright now when we... That's because I put in the exposure here, remove. There we go. Okay. Yeah, thanks for watching, and see you guys next time. I think I'm gonna go for health information about this big dude, and then being able to actually damage him, because, you know, that's a completely new paradigm that we haven't explored yet. So that's probably something that we can try and see what happens. Or probably something that will be helpful to look at if you're not familiar with ECS and, you know, that type of thing. Just damage something in ECS, you know. So, great work. Thanks. See ya. Bye bye.